In 2024, highly pathogenic H5N1 avian influenza moved into American dairy cattle, marking a major crossover event that caught the agricultural world off guard. The virus replicates directly inside the mammary glands, shedding massive viral loads, over 100 million infectious particles into every single milliliter of milk. When the FDA screened the commercial milk supply across the country, they found H5N1 viral RNA fragments in roughly 20% of retail samples tested. This data sparked immediate concern that the dairy supply, once a staple of food safety, had become a potential path for a human pandemic. To find out if this threat was an active danger or a false alarm, scientists put the H5N1 virus through a multi-stage food science gauntlet. The first stage of that gauntlet is high-temperature short-time, or HSTST pasteurization. This process heats fluid milk to 72 degrees Celsius for exactly 15 seconds before cooling it back down. This chart shows the survival rate of the virus at high heat. Looking at the steep red line on the right, the viral count drops to 0 at 72 degrees Celsius within seconds, a reduction of over 12 log 10 units. This resolves the grocery store mystery. When the FDA ran viability testing on those positive retail samples, they found 0 live virus. The 20% positive rate was detecting ghosts, shredded, dead RNA fragments left behind by the heat. Standard commercial milk remains protected by a system designed to strip away biological risks before the product ever leaves the plant. If you're learning something new about how your food stays safe, please hit like and subscribe. High heat effectively clears the virus, but many dairy products, like cultured yogurt, rely on different methods for safety. The focus is hemagglutinin, or HA, the surface protein spike H5N1 uses to infect cells. As bacteria ferment milk into yogurt, the pH level drops to a mildly acidic 4.2. That environment permanently warps and denatures those HA spikes, leaving the virus unable to function. High-acidity fermentation acts as a biological trap, ensuring commercial yogurt stays clear of infectious H5N1. The safety landscape changes when dealing with untreated raw milk, kept at standard refrigerator temperatures of 4 degrees Celsius. This graph tracks the infectious titer of the virus in cold raw milk. Following the blue line, the virus remains fully infectious across the entire 4-week timeline, with no significant loss of danger. This brings us to the cheese loophole. For decades, the assumption has been that aging raw milk cheese for 60 days naturally kills off any dangerous pathogens. Research from Cornell and the FDA tested that assumption. Because artisan cheeses age at mild temperatures and maintain a relatively stable pH, H5N1 survives through and beyond the 60-day aging process. Raw dairy fails the safety gauntlet. These findings indicate that untreated artisan cheese can act as a vehicle for the active virus. Pasteurized milk, processed cheeses, and high-acidity yogurt have established scientific barriers that the virus cannot survive. However, the growing trend of consuming raw milk and raw milk cheeses bypasses those specific safeguards, leaving consumers exposed to whatever was present in the cow at the time of milking. Consuming raw dairy during an H5N1 outbreak removes the protections built into the modern food system. Checking the label for the word pasteurized is the most direct way to identify which products have been through the safety process and which haven't.